Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video I want to continue discussing the terminology associated with matrix algebra. And in specific I want to talk about this idea of a matrix. We're actually going to come back to a vector after we talk about matrices because a vector is just a special type of matrix. Okay? So in the previous video we discussed this idea of a scalar simply being a number that was sort of by itself. So now we're going to talk about this idea of a matrix, and then we're going to dovetail that into discussing how we describe a matrix in terms of its dimensions. Okay? Let's give ourselves a little room here. So, what is a matrix? Right. Now, if you think back to those, 90s and early 2000s movies called The Matrix, right? And you ever watch those where they had the bit code running in the background, right? That is, in effect, an example of a matrix. Because all a matrix is it's a rectangularly arranged group of numbers, right? It's a group of numbers arranged in a rectangle. And I'm underlining the word rectangle in multiple colors here. Right? Because I'm not using the word square, right? I'm not using triangle, right? It's a rectangle. And so what does this look like? Well, let's say we have 6 numbers. I'm going to just make them up at random. Let's say we have 1, 7, pi, 1/2, -3, and square root of 2. Right? So you'll see here that I've arranged them in a rectangle. And I'm going to, my handwriting to be a little bit better, that'd be nice. I'm going to arrange them with these giant brackets around the outside. Right, and you'll see that what I've done here is I've taken these 6 numbers, 1, 2, 3, 4, 5, 6, and I've arranged them in a rectangle where we have 3 numbers in one row and 3 numbers in a second row. Okay, so this is all a matrix is it's just a rectangular arrangement of numbers. Okay, so hopefully that makes sense. So this is sort of the visual representation. How do we see it algebraically or symbolically? If I could spell here, or at least spell closer to correct, right? Algebraic symbology. Right, when we talk about a matrix in equations, we will typically see them using capital letters like A, B, capital X, right? So scalars, if I can scroll up here for just a second to the previous video's notes, maybe I can separate these a little bit closer, right? We said that scalars were just a number by themselves, right? 1, 1/2, -pi/2. And whenever we were using them in an equation, we demonstrated them with the lowercase letter, right? Well, matrices sort of are the opposite, right? They're a group of numbers, and we arrange them in a rectangle, and we put them in these giant brackets here to show that this is a matrix. And when we want to put it in an equation, we use the large or capital letter, right? A, B, X, etc. Okay, so hopefully that makes sense. A matrix is a group of numbers arranged in a rectangle, and we symbolize them algebraically with a capital letter. Okay, let that sink in for a second. Group of numbers arranged in a rectangle, capital letter. So let's take a look at how we describe matrices. So let's draw another matrix, okay? Let's draw a matrix that has 6 numbers, but let's arrange it differently. Actually, let's take the same matrix and let's arrange it differently. So we have 1, 7, pi, 1/2, -3, and square root of 2. Right, and then we'll draw this one here. Again, right, same thing, 1, 7, pi, 1/2, -3, root 2. So these are the same numbers arranged in two different rectangular matrices. And I have these because I want to describe how we explain the dimensions of a matrix. Right? How do we explain the dimensions of a matrix? Right. I'm going to give myself a little bit more room here so we can just look at these two examples. Okay, so the dimensions of a matrix. So the dimensions of a matrix are always going to be, right, m by n. Right, m by n, where m is the rows and n is the columns. Okay, m by n. M is rows, n is columns. So let's go ahead and let's look at these two examples here to make sure that we have a good understanding of the dimensions of a matrix. So in this case, right, we have 1, 2, 3 rows, right? So we have 3 rows. Okay. We have 1, 2 columns. Right, so in this case, right, this matrix right here would have the dimension 3 by 2. Right, it would be 3 rows, 2 columns. It would be a 3 by 2 matrix. This does not mean multiplication. Let me make this absolutely clear. Not multiplication. Right, this is not multiplication. This is read as 3 by 2. 3 by 2. So it's 3 rows by 2 columns. Okay? Let's go ahead and look at this one. So this one, right, the same numbers, just arranged differently. So this one has 1, 2 rows. So this has 2 rows. Okay. Right, it has 1, 2, 3 columns. Right, 3 columns. Right, so this matrix, right, is a 2 by 3. Right, 2 rows by 3 columns. Again, not multiplication. 2 by 3. 2 rows, 3 columns, 2 by 3. Okay? Hopefully that makes sense. Hopefully the way we arrange a matrix in a rectangular format and the fact that we have the rows and the columns makes sense. In the next video, we're going to talk about a special type of matrix called a vector, which is basically going to be a special type of matrix. So hopefully that makes sense. And as always, please reach out. Thank you.